Welcome to Electronics Unmessed. This is Klaus. In our extra series on thermal insulation, we have already seen some interesting effects that we can take into account in our energy consumption prediction tool. Today we are talking about how to model the sun's influence. There is also a feature for this, which I will now explain in detail. In the last video, we discussed the energy efficiency report, which gives us detailed information about the heat flows, consumption values and cost. It is definitely worth simulating different scenarios for comparison if you want to renovate a house. In previous videos, I explained how to map the thermal insulation properties of the roof, the walls, the doors, the windows and the false ceilings in our Excel tool. And of course, you can also take local climate data and user behavior into account. You should definitely watch this and the following videos if you are interested. So subscribe to the channel and hit the bell. The sun has an impact on the energy consumption of a house. With some clever measures, you can even use the sun to save heating energy. Today I want to explain how you can actually predict the energy contribution of the sun. When I first presented the tool, I had already briefly shown this function. You can switch the sun's contribution to our heating on and off using the switch here. In our example here, the sun's contribution would be quite significant. If we want to make a good estimate for this, we have to provide a few details, because the influence of the sun naturally depends on the location and in particular on the windows of the house. We can consider all this and we go to the settings sheet. First, we need the mean insolation, which is the sun's radiation energy that we receive for each month of the year. We know that the maximum solar irradiance is just over 1300 watts per square meter. The minimum solar irradiance is 0. Depending on the location and weather conditions, the mean radiation is somewhere in between. From where can we get this data? In a previous video, I have shown a website from which you can get the so-called solar yield from practically anywhere in the world. I will link you to the video at the top right. With a little trick, we can calculate the strength of the solar radiation. What we get from that site is the so-called solar yield per month, and we enter it here. The tool now assumes an efficiency of the solar cells of 25% and uses this to calculate the average total solar radiation in kilowatt hours per month. There may be better data for this available in your country, but for a first assessment, this approximation works pretty good. In the next section, we specify the area of the windows that is exposed to the sun. First of all, the maximum value is important here. In my example, I have 20 square meters of window area on each floor. The sun sees only half of it at a time, and a part of the windows is shaded. So I estimate that I get a maximum of 5 square meters for each of the inhabited floors. The basement windows are relatively small and even more shaded. I estimate only 0.3 square meters sun exposure here. And then we have to specify a penetration coefficient for the windows, which I estimate at 50%. In physical terms, this means that 50% of the sun rays energy transmits through the windows. During the winter, you want to let as much as possible sunlight in. In summer, when it's hot outside, you want to let as little sunlight as possible into the house and the windows will be shaded. Otherwise, you would needlessly consume energy through air conditioning. We have to take that into account somehow. Now, you could of course fiddle around with the window areas to find the minimum energy consumption in the year. But we are Electronics Unmasked, and that's why we're doing something much smarter. I have to tell you another super cool trick. We use the Excel Solver plugin. First, I simply enter the maximum values, being 5 or 0.3 square meters for each month. By the way, we need to remove the sheet protection, otherwise we cannot use the solver function. Then we mark the field giving our total energy consumption and start the solver. And look at this. Without any Windows shutters, in total I would increase my yearly energy consumption to 131 kilowatt hours per square meter, because I would need a lot of air conditioning in summer. Then we mark the fields that we want to vary. I don't want to change the shading of the basement windows, because in reality I don't do that either. So I only mark the windows on the floors to vary. And then we have to define that our target value should be a minimum. And we still have to set boundary conditions for the variable fields. The values in these fields should not be greater than 5. In addition, we must prevent the values from becoming less than 0. Now we can start the optimization process using the CRG method. After a few seconds, the solver has optimized the window shading so that we get the lowest energy consumption possible. That's super cool, isn't it? By the way, I think it would be a good idea to control the window shading via the home automation system. As we have just seen, bringing them to an optimum, this could save quite a lot of energy. If you're interested in tricks like this, stay tuned to the channel. That was the 7th part of our step-by-step user's guide. I hope I was able to motivate you to play a bit with the Excel tool. As said earlier, there will be more episodes in which we will show examples and in particular discuss results and reports. There are still a few more functions that I haven't explained yet. For example, I haven't explained how to predict the effect of waste heat from electrical devices and people. If there are any questions about this part, please ask in the comments. I will be happy to answer that. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.